I'm Karol Kaczmarek, the co-founder of Net Zero Camper, where we focus on pragmatic solutions for businesses that need to navigate regulations, green regulations, and policies. So thank you for taking your time today. I'm pretty sure that your insights on waste-derived hydrogen, e-fuels, and fertilizers will be valuable for our readers. So that brings us to the first question. Your plasma electrolyzer system converts mixed waste into hydrogen and e-fuels. So I was wondering, what are still the main technical or practical challenges you need to solve before you can scale it up commercially?
So the main challenge is really the scaling. The system was developed by the UK military for military application, and it's a modular system. So the way we're designing it is by building modules that we can put together to build bigger plants.
And roughly speaking, how do your production costs for sustainable aviation fuel, which is SAF, and synthetic marine diesel compare to other methods like power to liquid that use hydrogen and captured CO2?
Very favorably. The principle of what we do is that we get paid to process the waste. So at the point that we make a syngas or synthesis gas, which is the first step in the process. So you make a gas, which is then converted into a liquid using a Fischer-Tropsch process or similar. So at the point that we make the syngas is zero cost to us because we make money from processing the waste.
And that's the main stream of profit, right?
Well, the main stream of profit is selling the fuel, because synthetic aviation fuel, is currently selling for $2,400 per ton, whereas regular fossil-produced aviation fuel is about $700 per ton.
And all the features, for example, from an airline perspective, are there any differences while using, for example, your fuel versus standard ones that were on the market, let's say 5 years ago?
No, it's exactly the same, and it has to be. There's a very strict international regulation which controls the quality of synthetic aviation fuel. And it's understandable, because obviously you don't want to put anything in an aircraft engine which could upset it. And so we conform strictly to the international standards, as does everybody else.
That's great. So from a customer's perspective, there is no difference. So obviously they should opt for your fuel.
Yeah, there cannot be. There cannot be, for safety reasons.
And when you present your process as carbon negative, you've just mentioned that, which key factors do regulators and investors focus on when verifying that claim?
So it's really on the processing of the waste. So if you take a ton of waste that's put into landfill and it's mixed waste, then that ton of waste will create about a ton of methane every year. And methane as a greenhouse gas is 28 times more harmful than CO2. So for every ton of waste that we process that's not put into landfill, we're saving 28 tons of CO2 equivalent.
That's a huge impact. And since waste streams can vary a lot, how do you ensure that the feedstock quality stays stable enough for the system to work efficiently all year round?
So that's something which is covered by our IP. And the unique feature of the PES system is that it doesn't need a catalyst. Most waste processing systems where you're doing waste to fuel or waste to energy, the waste is burned, and if you put mixed waste in, then what will happen is it will poison the catalysts in the reactors. And that makes it very expensive, because either you have to replace the catalysts on a regular basis, or you have to sort and pre-clean the waste. With our system, you don't do that. You don't need to sort the waste because we don't burn it. We put it into a plasma system that breaks down any of the molecules into their individual chemical species. And that means that we can process anything through our system, and I mean anything, to produce the purity of fuel that's required.
And you mentioned it's managed by IP. Could you explain what that means? What is IP?
Intellectual property.
Oh, okay. Yeah. Just for our also listeners to know 100% what we are talking about. And with upcoming rules, probably you're familiar, like re-fuel, EU, aviation, maritime fuel mandates. Which ones are the most relevant, do you think, for your project locations and timelines?
Well, the European and UK rules, similar with rules now in Japan and other countries, require a 2% blend of SAF for aviation. The marine rules are slightly different, and they look at the wake emissions overall from the ships. But the SAF rules have come into law in Europe from the 1st of January. So everything that leaves European airspace has to have at least 2% SAF in its tank. And if it doesn't, then there are penalties which accelerate, which are designed to ensure that there is that mix of fuel, which will lower the emissions in the overall aviation supply chain. So we're focusing initially on Europe. Our focus is on the tier 2 and tier 3 airports, not the very big airports like Heathrow, but the smaller regional airports, because all of those have to have SAF.
You focus on Europe, but as Forrest said, your fuel can be used all across the world because it needs to adhere to those strict regulations. So technically, you can sell the fuel to any company located anywhere in the world, right?
That's right. And our vision is to have regional plants which are located outside of these regional airports, which can process the local waste and produce the fuel that's needed and supply it all locally, so it minimizes the transportation costs.
Thank you so much for this insight. Recently, I've read an article about ammonia and methanol and opportunities. They can be also used for synthetic as an alternative for synthetic fuels. Do you see any situations where, for example, green ammonia or e-methanol or synthetic diesel, both they are a better solution than SAF, both in terms of cost and infrastructure?
Well, eventually all aeroplanes will fly on hydrogen or something like that. But there's so much investment in the current fleet of aircraft that isn't going to happen in the near future. But over time, it will. When it does, you simply click a switch on the PES units, and instead of producing SAF, it will produce either hydrogen or methanol or ammonia. So we can produce those fuels, but we don't see a near-term demand in aviation. In maritime, it's different. In maritime, there's yet to be a real standardization from the IMO, the International Maritime Organization, to say ships must use methanol or ships must use ammonia or the equivalent SAF, which is synthetic marine diesel, which can also be used in conventional engines and port infrastructure. But there may be nearer term demand for hydrogen derivative fuels like methanol or ammonia.
Mm-hmm.
But in the near term, we don't see that in aviation.
Even in, let's say, if we have a timeline of 10 years, right? For now, you wouldn't envisage that.
I think it will be very challenging in aviation because there is so much investment in the existing assets, the aircraft, the current engine technology, and in the refueling infrastructure at airports that supports conventional fuels. It would be very difficult to upgrade that even within a 10-year period.
That's correct. Plus, I also read that within aviation industry, you always engineer and build for the next 25 years. So currently, aircraft that are built, they will be running for another 25 years from now. So probably it's also another hurdle.
It certainly is. And I know there's a lot of development work on things like dual fuel engines and so on. And that will come in time. But the other big challenge is really the refueling infrastructure. How do you get all these different fuels onto the tarmac in the quantities that are required? And a wide body jet needs a huge amount of fuel.
Since you have experience in both hydrogen and battery storage, how would you advise a utility deciding between hydrogen, lithium-ion, or, for example, iron-air batteries for large-scale grid storage?
Well, it depends on what you're trying to do. If in the near term you're looking to fuel a zero-emission vehicle, a passenger car or a bus, it's much more efficient to use electrons to charge batteries from the grid. If you're looking to make fuels or some other function that you want to do, then hydrogen is a good option. It's also an interesting option, I think, for heavy trucks because of the weight advantage. For a big truck, you need a lot of batteries, which can be heavy, and that can reduce the amount of load that the truck can carry. But for things like passenger cars and lighter weight vehicles, I think electrons and batteries are much more of a sensible option.
Thank you so much. And could combining your process with CO2 captured from industries like cement or steel make your business model stronger, or would that add too much complexity? I must say, we've interviewed similar companies to yours, and actually they had some contracts signed with leaders in those industries, so they could also capture CO2 from their manufacture throughout their manufacturing process.
Actually, we do it the other way around, because the waste that we process is essentially a hydrocarbon with many other chemicals in it. We create our own CO2. Or in the case of syngas for the synthetic aviation fuel, the carbon monoxide that we require for that. So we don't need an external source of CO2. We can also create CO2. And in the plant that we're constructing in Bali in Indonesia, which is making urea fertilizer, urea is ammonia plus CO2. So we generate the CO2 that's required for that process.
And I've learned that you recently signed a deal with Farnborough Airport for SAF deliveries. What did you learn from that process about setting up strong offtake agreements for fuels like yours?
Well, I mentioned at the beginning that we're focusing on tier 2 and tier 3 airports. Just to give you a perspective, there are about 8,500 airports, commercial airports in the world that are active. and about 500 of those are classified as Tier 1 airports. And they're the very big airports like Heathrow, JFK, Schiphol, and so on. And those airports handle massive amounts of traffic, wide-body jets. But everybody knows that there are lots of regional airports near where they live, and also covering certain markets within the aviation sector. So Farnborough is the premier business airport, handling private jets for business market and servicing London. It's also very well known internationally because of the Farnborough Air Show, which is one of the main air show events held every 2 years. So it's a flagship Tier 2 airport for us. And our strategy is to focus on these 8,000 Tier 2 and Tier 3 airports around the world, where we want to build these regional plants to take locally produced waste with the minimum number of miles involved of transporting the waste or the fuel, construct those adjacent to the airports and supply the SAF that's required. And that first plant will be the first of a kind, which we'll then use as a cookie cutter to build additional plants around the world.
Thank you very much for this explanation. And you already mentioned that it's difficult to predict any changes within this market. But if we fast forward 5 years from now, what plant size, production mix, and geographic reach would you personally consider a success? And which milestone will be the most important to get there, in your view?
In 5 years?
Yes.
Yes. Yeah. By that time, we would expect to have 100 plants under construction or in production. The SAF mandates for most countries will jump from 2% now to 10% by 2030. So there'll be a jump in demand of 5-fold for SAF, and then it goes up again 5 years later. So each time the SAF production needs to expand. The advantage of our approach is it's modular. And if you're designing a plant for the future, if you're a planner, what do? Because do you construct a plant that would be good for you in, say, 20 years' time? In which case you'll have overcapacity now in your plant, and it will catch up in 20 years' time. Or do you build a modular plant, which is sufficient now, and then increase it to meet the modular regulations? And we think that most planners would want a modular approach, which is what we're doing. So the plants will have a basic footprint, and then they will expand as the demand for SAF grows.
That's quite logical solution, I would say. I would also go for the latter.
Yes.
And that brings us to the end of the questions that I prepared for today. Is there anything we haven't touched on that you feel that is important to share?
No, I think that's very helpful. Thank you.